so basically, number 10 is linking some notation. This is our next lesson. It's called the definite integral, and this is what we're doing today. This is the limit of the Riemann sum. I'm sure some of you are wondering, why on earth would we be going through and, doing this rectangle thing to get an overestimate or an underestimate when in math we like to be exact? And that would be a great question. What I want you to see is what we're doing is we're actually taking the limit as n approaches infinity. I have written up here in red some things you might want to add to your notes. N stands for the number of intervals. So in most of our problems that we did today, it asked us to break things up into 4 sub-intervals. But if you think about it, the more sub-intervals you use, approaching infinity, the closer and closer you're going to actually get to being exact. Because there's less margin of error there. So you can see this is exactly what we did today. We have our height times our width, so that's the average length times width of our rectangles. And as we get more and more and more approaching infinity rectangles, that limit is actually exact. That's our definition of an integral, or a definite integral. So just go ahead and add, that A is your lower bound and B is your upper bound in your notes. For finding the area between A and B, and know that that's what we're going to in our next section. As far as this goes, number 10, this is notation. I'll never ask you to write this out, but there's just an explanation as to why we're doing what we're doing.